Pre-statistics. Using exponential functions to model data, Part 2. Lesson objectives. Model a half-life situation. Find an equation of an exponential model by using data described in words or table. Lesson objective. Definition. If a quantity decays exponentially, that means it is strictly decreasing. The half-life is the amount of time it takes for the quantity to be reduced to half, 50%. So it is a x value, an independent value, where the dependent value is 50% or 1/2 of the original amount. Example 3. The world's worst nuclear accident occurred in Chernobyl, Ukraine on April 26, 1986. Immediately afterward, 28 people died from acute radiation sickness. So far, about 25,000 people have died from exposure to radiation, mostly due to the release of the radioactive element cesium-137. Cesium-137 has a half-life of 30 years. Let P equal F of T be the percent of the cesium-137 that remains T years after 1986. This is a picture of the plant at Chernobyl. Number 1. Find an equation of F. Solution. The first method, when T equals 0, 100% of cesium-137 is present. At T equal 30, 1/2 of the 100% or 50% is present. At 60 years, it's 1/2 of the 50% or 1/4 of the original amount, 100%, which is 25%. This situation can be modeled using an exponential function. So here's our table of values. Here's the years, and the dependent variable is the percent. So we have 100%, 50%, 25%. So A is our initial value. We had 100% to begin with when T is 0, and for every 30 years the amount is cut in half. Each exponent in the second column is equal to the value of T in the first column divided by 30. So the equation of F is F of T equals 100 times 1/2 to the T divided by 30 power. Use a graph and calculator table and graph to verify the solution. So if we have F of T equals 100 times 1/2 to the T divided by 30 power, well, that's equal to 100 times 1/2 raised to the 1/30 times T. And if we multiply powers, that means we can write it power to power. So this is another way of writing this function. So if we take 1/2 and raise it to the 1/30 power, we have 0.997 rounded to 3 decimal places. Therefore, we could write the function as 100 times 0.977 raised to the T power. Putting that function in y1 and using our table, we see the corresponding table of values. And then we have our graph here. So when x is 30, y is 50%. Method 2, we know the points 0, 100, and we have 30 years, 50% is remaining. So the p-intercept is 0, 100, so A is 100. To find B, we use the points 30 for T and 50 for F of T. Solving this, we divide both sides by 100, and we have B to the 30th power equals 50 divided by 100, which is 1/2. So next we need to find the 1/30th power. to both sides. And because 30 is an even number, we have a plus and a minus. So that equals 0.977. And because exponential functions, the base is always positive, we can drop off the negative. So the equation is the same. Number 2, describe the meaning of the base of f. Well, the base is 0.977. And that means for each year, 97.7% of the previous year's cesium-137 is present, or cesium-137 decays by 2.3% per year. So if we take 100% minus this, we get 2.3%. So this is the amount that decays each year. Number 3, what percent of cesium-137 will remain in 2010? Solution: 2010 means that T is 24. Substituting that value in, we get 57.21. So in 2010, about 57.2% of cesium-137 will remain. Lesson objective. Example 4. The sales of energy and nutrition bars have grown approximately exponentially from 0.2 billion in 1997 to 1.2 billion in 2004. Predict the sales in 2011. Solution: let S be the sales in millions of dollars of energy and nutrition bars. Let T be the year since 1997. By making a table, when T is 0 we have 0.2. When T is 7 we have 1.2. And the problem is given that T and S are approximately exponential. So we want the equation S equals A times B raised to the T power. We know that the value of A is 0.2. Next we need to find B, and we'll use this point. When T is 7, S is 1.2. First we want to divide by 0.2. We have B to the 7th equals 6. Raise both sides of the equation to the 1/7 power, and B is approximately equal to 1.292. So for our function we have S equals 0.2 times 1.292 raised to the T power. And 2011 means that T is 14. So substituting 14 in for T, S is approximately equal to 7.22. So we would say in the terms of this problem, the model predicts that the sales will reach 7.22 billion in 2011. We can verify this on the graphing calculator using our table feature. When X is 14, we have 7.22. Thanks for watching.